This video is about the standardization of acid. It consists of complete knowledge with food illustrations. It also tries to clear confusion about molarity and normality that we face during calculation, and it also helps to know the method of calculating molarity of concentrated acids. For the standardization of acid, we need to prepare acid solution of certain concentration. So, in this illustration, we will prepare hydrochloric acid of around 0.1 molar concentration using concentrated hydrochloric acid that is available commercially. And in this case, we will standardize the hydrochloric acid with standard sodium carbonate. So overall, this process is a kind of acid-based titration method. The commercially available hydrochloric acid is very concentrated hydrochloric acid solution. In the bottle, we can see that it is labeled with 37% and the density D is given as 1.2. From this concentrated hydrochloric acid, we need to prepare dilute hydrochloric acid of around 0.1 molar concentration. To prepare dilute 0.1 molar hydrochloric acid, first of all, we need to find the molarity of the concentrated hydrochloric acid, that is the commercially available hydrochloric acid. Let's see how we can find the molarity of the concentrated hydrochloric acid that is available commercially. The given hydrochloric acid is 37%. It means that in each 100 ml solution of the given hydrochloric acid, it contains 37 ml of pure hydrochloric acid. And the density 1.2 means that it is the density of pure hydrochloric acid. From this information, we can calculate the mass of hydrochloric acid in each 100 ml solution as follow, like multiplying the density into the volume, that is 37 into 1.2. Now we can calculate the approximate molarity of the 37% commercial hydrochloric acid as follows. Volume of acid solution is 100 ml. Mass of acid is given as 37 into 1.2 gram. Now the molarity can be calculated as given formula. So finally, the molarity or normality of the hydrochloric acid that is available commercially is around 12.164 molar. Now we have the molarity, approximate molarity of the commercially available concentrated hydrochloric acid, which is around 12.164. Now we have to dilute this concentrated hydrochloric acid to make dilute hydrochloric acid. So we can use the formula, molarity formula, for the preparation of dilute hydrochloric acid solution. Here we are going to prepare 0.1 molar hydrochloric acid of around 500 milliliter from the concentrated hydrochloric acid 12.164 molar. So we need to find out how much volume of concentrated hydrochloric acid is required. So from the molarity equation, we can find that the required amount is around 4.11 ml of concentrated hydrochloric acid, that is 37% commercial hydrochloric acid. So we will fill more than half of the volumetric flask with water and we will add the concentrated hydrochloric acid, because we need to add concentrated acid to the water to prevent excessive heating. Then we will make up the final volume up to 500 with additional water. Now we have prepared hydrochloric acid of nearly 0.1 molar concentration. Now the next step is the preparation of standard sodium carbonate solution. We know that it is primary standard substance, so we can prepare standard solution of sodium bicarbonate directly by mixing the required weight of sodium carbonate to the calculated volume of water. So from the calculation here we can see that if we add 1.06 gram of sodium carbonate to 100 ml of water, then we can prepare 0.1 molar of sodium carbonate, which is also equal to 0.2 normal sodium carbonate solution. After that, it is time for standardization of dilute hydrochloric acid with standard sodium carbonate solution. We have 0.2 normal sodium carbonate solution. So we will put the sodium carbonate solution in the burette, and in the 3 conical flask we will add hydrochloric acid of 10 milliliter in each conical flask. We will use pipette to draw the 10 ml acid solution and put in the conical flask. We will put few drops of phenolphthalein in the conical flask, which contains dilute hydrochloric acid. The indicator doesn't show any color in acid. We slowly titrate the acid with the base present in the burette, and when the equivalent point is reached after the neutralization of acid with base, the amount of base is a little bit excess in the final solution, and the color starts to change into pink, which indicates the end point of the reaction. We'll repeat this experiment for 3 times and find out the average volume of base required to neutralize 10 ml of dilute hydrochloric acid. Then from the normality equation we will find the concentration of hydrochloric acid. Here the volume of base that reacted with the acid was 6.1 milliliter. So from the normality equation we found out the molarity of the hydrochloric acid, or normality of the hydrochloric acid is 0.122. In this way we can find the concentration of hydrochloric acid using standard sodium carbonate solution. So this is the method for preparing standard hydrochloric acid from strong concentrated hydrochloric acid, which is available commercially.